Hello and welcome to a brand new week. This week is Quadratics week, and what that means is we're going to explore what a quadratic is. We're going to work out how to solve quadratic equations, and it really brings together the last few weeks where we've been looking at expansions and factorizations, because we now apply those skills to quadratics. So just briefly, what is a quadratic? Well, a quadratic is a particular kind of trinomial where we have a squared term, usually x, but it could be t, could be anything, and a is the coefficient. And we have an x term, and then we have a constant term. So ax squared plus bx plus c, anything that takes that form is a quadratic. And remember, x is just the variable. It could be any variable that's used. Commonly, t is used for time. And a, b, and c, although they are variables in this context here, but really they stand in for constant numbers, so fixed numbers. So a, b, and c, constant fixed numbers, x is the variable. Okay, and just a reminder of language there, a and b are what we call coefficients of the term, and c is called the constant term. The reason why we're going to apply these techniques is quite frequently because we're trying to solve an equation. So an equation, remember, as opposed to an expression, is when an equal sign is involved, surprise, surprise. So if I have something like x squared plus 5x plus 6, so that's a quadratic, and set it equal to 0, then I frequently want to find out what the solutions are for that equation. And again, just a language thing as well, what a solution means is for what values of x can I use that will make this expression true. So for example, if I use, let me think, -3 here, -3 squared is 9, 5 3s are 15, so 5 times -3 is -15, so we've got 9 minus 15 plus 6 is equal to 0, so that's a solution. It doesn't always have to be something equal to 0, it could be like x squared plus 5x equals -6, but of course this equation can be written in this particular form, and you'll find that with all quadratics that it might be given to you in lots of different forms, but that is the form that we will work with. And so what we'll do over the course of this week is we'll have a look at different techniques so that we can solve them. All right, why do we do this? Well, there's a whole bunch of reasons why, but a quadratic is frequently what real life situations can be modeled as. You should know by now, I think, it doesn't matter if you don't, but you should know by now that if I graph a quadratic function like this, say for example, I'll do the dots here because maybe that bit's not real, but the rest of it is. That's a quadratic function. And what we frequently need to do is work out the critical points because they tell us critical things. So it's often the x-intercepts or the zeros, the y-intercept, and the turning point. So these are all critical points. And so our capacity to manipulate a quadratic equation using some of the techniques of expansions and factorizations that we have done before will allow us to pull out these kinds of critical pieces of information. And from them, we're then able to sort of make inferences about the graph we're looking at and stuff like that. Okay, that'll do for this video. So it's just an overview of the week and where we're headed. Next video, we'll have a look at our first technique for solving equations.